Cool. I really enjoyed Ash's talk yesterday. I don't know if any of you, maybe round of applause, those people who enjoyed it. I was like, yeah. It was great stuff. He hammered one point home, right? Which was, for me anyway, my main takeaway was to share more, right? Like share more of your thoughts and share more of your code. And thanks to dependency managers like Carthage and CocoaPods, it's easier than ever to do that, right? Like, you can grab anything you want and put it into your project in seconds, which is like, things have gone a long way. It's changed how I think the community develops iOS apps, and it's certainly changed how I program, right? And it's made me a better programmer. Because I've started to challenge myself to write libraries, kind of like Hallie was mentioning, that other people want to use. But like JP said yesterday, you know, other people using your tools and your code is kind of a trust exercise, right? Like, there's a lot of risk involved in taking someone else's code and kind of relying on it. So when people decide that they want to use your code, it's because they trust you. And it's important to not betray that trust, right? So what I want to talk about today is how to make sure, or how I make sure that the code that I write isn't going to be somebody's bad decision. So I'm Brian Gesiak. I go by Motocache on GitHub and Twitter. I work on newsfeed infrastructure at Facebook in New York. So basically, newsfeed is one of Facebook's probably most compelling experiences on mobile. So it makes a lot of sense that a lot of iOS engineers at Facebook really want to improve that product. And I write the infrastructure code, I write the libraries in iOS that help them to do that more efficiently. So some of you may have seen this quote, move fast with stable infra, right? And that's kind of my job, is to make sure other people can move fast with stable infrastructure. I'm also the creator of Quick, which is the Swift and Objective-C testing framework. After JP's talk yesterday, I was like, yeah, I can rock the t-shirt. You know, people seem to enjoy it, so that's cool. Speaking of t-shirts, I have a few extra ones. So very few, but like there are a few. If you want one, I have several sizes. Just go onto issue number 300 on the Quick repository and post which size that you'd like. Yeah. So now that I've offered you all free t-shirts, thank you very much for listening. And no. Yeah, you might think that there's nothing that can top free t-shirts. And that's where you're wrong, UIKonf. So we've heard a lot of great talks so far. A lot of them touch on concepts that are totally new to us. Since WWDC last year, we really have to kind of expand our minds and visit new paradigms and new ways of programming. And a lot of the talks focus on that. And they focus on one word in particular, right? Like a really scary word, something that confuses a lot of people, gets them all like befuddled. You know, some speakers never mentioned it. They tried not to mention it. Some speakers were bold and they embraced it. They devoted their entire talk to it. I'm talking, of course, about bananas. Eli, in particular, made extensive references to them in explaining how to manage state in Swift. But as Marcel's talk illustrated, some people aren't convinced that Swift is the language we need to render complex user interfaces on iOS. And that's why today I'm excited to invite you all to a private beta of my new open source UI framework, Banana UI Kit. Thank you. Thank you. Yes. It's an honor. It's an honor. It's been a long road. Banana UI Kit has been blessed by extensive investments. Contrary to what JP would have you believe, open source projects do not come out of nowhere. They need to be funded by somebody. And we've gotten a lot of love. But it wasn't perfect from day one. It took a lot of iterations to get Banana UI Kit right. And iterating on such a large framework used by so many different apps in the App Store has really taught me a lot of things about maintenance and trust. The first one is to write abstractions for what will likely change, right? And in UI frameworks, there's a lot of stuff that can change. A great example is banana alert view, right? The initial API, written in Objective-C, looked like this, right? Where you could show an alert with the title, a message, and what is displayed on the dismiss button. So this worked out pretty well, but it wasn't long before somebody posted an issue on the repo and was like, hey, I want to display this in a color that is not yellow. And it's like, why would you ever want to do that? But some people do. So, okay, cool, I thought. I can just add another parameter to this method and we're done. But then what happens then is you have to change every single call site that uses that method, right? So everything that used the old method would no longer compile, and that means a breaking change, which means a new version number of Banana UI Kit, which is problematic for two reasons, right? The first is that for large code bases, for code bases at scale, kind of like that pizza yesterday, it's a significant investment to change every single call site, right? You wouldn't think that Xcode would be able to display 70,000 results for find and replace. We did it. The other problem with bumping the version of your framework is now you have another version of your framework to support, right? And it's great if everybody migrates right away, but like who runs pod update that often? Pff, not me. So I don't want issues on the repo, on my repo where the first question I ask is always what version are you using, or like this was fixed in version X and you're using an old version. So this is not a great way to go about doing things. I mean, it doesn't seem like a big deal, but it happens a lot, right? Let's say somebody wants a custom font on their alert view in addition to a custom color. It's like, okay, great. Well, we can't just make Banana UI Kit version 3. People would be like, that's bananas. So how do we avoid this? Well, in Objective-C in the old days, we just add a new method, right, that has this new tin color parameter, and the new method would just call the old method, right? And the old method would just have a regular yellow color, and the new method would actually display the alert view. So this is great because there are no build errors. People using the old method would still be able to get a yellow alert view, and people who want a custom color can get one. But of course, those were the old days, right? Like, who writes Objective-C anymore? In Swift, we could just define methods that take default parameters, which is great, right? Like, this kind of gets around the entire problem. We don't have to bump our version number and everything's fine. So long as we are adding methods, or adding parameters to methods, then we're fine. But pretty much everything else, we're still not fine, right? What about adding parameters to closures? Let's say this button callback closure, right? It's given, when somebody taps a button on the alert view, it's given the index of the button that was tapped, right? And then let's say this banana alert view show method takes that callback here to define the behavior of what happens when they tap the dismiss button. So typical call site would look something like this. You see here, somebody passes a closure into this thing. The closure is given one parameter, the button index. Cool story. What if we need to change the parameters in the closure? This guy just won't stop filing issues on the repo. It's like, I want to get, the closure should take an additional argument. It should get the text of the button that was tapped. And it's like, all right, well, cool. I'll just, oh, sorry, whoops. You didn't see that. I'll just add a parameter to the button callback. Easy, right? Now it takes a title too. Except once again, it breaks everything, right? Because now this line here, where this closure takes a single argument, is no longer correct, right? It's even worse because in Swift, the error message that you get is like, it cannot invoke show with an argument list of type blah, 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 and you're like, oh, I don't really know what that means. But right, so here the number of parameters is incorrect, which means that, hey, we can't add parameters to closures. We can't provide default arguments, so what do we do? Parameter objects is one particular design pattern that I'm fond of. So here, we can just define a struct that is just like a payload that's going to be given to this closure that takes several parameters. Here, the button index is an integer, and the string, the button text is a string. And then this button callback just takes a single parameter, a parameter of parameters, right? Great stuff. As a result, we can do a lot of things. So this closure will just take a parameters object. And the parameters object has all the properties that any user would ever need, right? We can reference those parameters in the closure. If we ever need to add a parameter, that's really simple too. We just add it. And that's fine, because this button callback doesn't change. And that means the call sites can stay exactly the same as well. And when it comes time to remove parameters from the closure, because this guy is like, oh man, including the button text in that closure was a terrible mistake. We never should have done that. That's easy too, because we can just add this, there's an availability keyword in Swift, and we could just say like, hey, this is deprecated now. Please stop accessing this. In the next version, we'll get rid of it completely. And then that doesn't produce a build error, that just produces a warning. Like, hey, stop using this. Cool. Of course, you can also use this for methods, right? I was talking about closures. You can also use it for methods, and you can get really granular. So here, like, these are alert view options is everything that is not super essential to displaying an alert view. Like what the dismiss button says, or the tint color. And you can provide defaults on all of these as well. And the show method can take a default value of that struct. Really cool. I think parameter objects are pretty great. They add a lot of flexibility to the parameters you use in your APIs, methods or closures. So it's tempting to just wrap everything in a parameter object, right? You get one, and you get one, and you get one. And before you know it, all of your closures, they're so happy about parameter objects. It's crazy. All right. So they're excited. And before you know it, all of your closures, all of your methods, everything is taking a parameter object, and it's just everywhere, right? And whenever I start to apply anything too much, whenever I'm like, this is the only way to program, I always think of this guy, Kent Beck. He is my absolute programming hero. He invented like agile development. He invented extreme programming. He wrote SUnit, which is a small talk testing framework. He later wrote JUnit, the Java testing framework. He's great. But the thing that I love most about him isn't any of that. It's this GIF, right? He never stops talking about trade-offs. That is the only thing he talks about most of the time. That and he makes graphs at Facebook. But he never stops talking about trade-offs, and he talks about them so much that he even has his own emoji. Right? So what does this mean? This is like the right hand, the right arm, is how much utility we get by using more and more parameter objects in our program, right? Over here, it's like, oh great, we use it in this one place, it's awesome. And as we keep using it, we have diminishing returns, right? Because if we use them in more and more places, it's like, yeah, well that was a cool idea, but a little too much. And then here is the additional overhead by having a parameter object in every single part of your app, right? Like every method or closure takes a parameter object instead of a single parameter or a set of parameters. And so you can adjust the values here, right? These are two functions. And you have to find, our job as programmers is to find the trade-off, right? The point at which we maximize utility of these two functions. And that's what Kent Beck talks about. That's all he talks about. Not all he talks about, sorry. Anyway, so today I kind of want to focus on that. I want to focus on the trade-offs of several of these patterns, right? Starting with parameter objects, right? What are the benefits of parameter objects? They future-proof your API. As you saw, we can add and remove parameters to methods and closures, and we don't have to bump a version number. But they're more overhead. Like I mentioned, you don't want to create a new struct for every single method and every single closure in your app. That would be nuts. I mean, it's a lot of conceptual overhead. There's also you kind of think about how much additional memory it'll use, probably negligible, but still, it's a thing. And then also, it kind of feels enterprisey. I know that's a bad word, but it feels like parameter object builder factory. It's like maybe too much. But right, so I kind of want to focus on trade-offs. Another problem that we had with Banana UI Kit is we didn't want to force users to choose. So it's important that people are able to use Banana UI Kit along with other UI frameworks, because there are a lot of competing frameworks out there. I know Facebook has a couple of UI things and whatever. So we want to make sure that people can use that stuff and our stuff. As an example, take out there's a UI text field subclass called JV float labeled text field. It's really great, right? It shows placeholder text, and when you tap on a text field and you start typing, the placeholder text floats to the top. And it's really cool. And the API kind of looks like this, right? It's a UI text field subclass. And you customize it with a bunch of different properties. The properties respond to UI appearance, which is also a nice touch. Really easy to use. You've all seen this before, Objective-C. You just create a frame and you create a float labeled text field, and then you set any properties that you need, and it's great. But there's one problem, right? It's a specific class. And subclasses force people to use that class and that class alone, right? For example, there's another text field subclass called MH text field. And this is also pretty cool. Like, it provides an input accessory view that goes to the next field and the previous field, and you can say done to dismiss the keyboard. It scrolls the scroll view for you. It's pretty cool. But we can't use both of them, right? Because this is a UI text field subclass, and JV float labeled text field is a UI text field subclass. So, and we don't have multiple inheritance in Swift or Objective-C, so we can't use both. You have to choose one or the other. Now, a category in Objective-C or an extension in Swift wouldn't be a problem, right? We just change this to be a category, and now anybody can use it. It can work on any text field, except for the fact that we can't define properties or non-dynamic variables in Swift on categories or extensions. The reason being that when you define a property like this and you don't also define a setter and a getter, you instantiate an instance variable, right? You have an instance variable synthesized for you. And we can get around that by having a setter and a getter. So what are they setting and what are they getting, right? Well, this is where Tom's talk yesterday comes into play, because he was like, yeah, runtime. We can use that. So we do that, right? It's pretty cool. We can set an associated object, which is a number that is the Y padding, like how high the label floats. And we can get that object as well, right? Pretty cool, pretty hacky, but it's cool. And we can do that for every single parameter here. And we're done, right? Like, it's awesome. Except for the fact that that is a lot of code for just 3 properties, right? It's a lot. We don't want to write that much. And this is an Objective-C, right? So it's completely unsafe. When we get an associated object, what happens if it's not there? Who knows? So let's get a little safer. Let's go to Swift. And now we have to check when we get an associated object. Hey, is that actually there? And also, can I turn it into a float? Because if not, I'm going to return 0. But if I do have it, then let's use that. And that for 3 properties looks like this. Don't want to write that much code, right? It does not scale. It's too much boilerplate, but also, if you look into how the Objective-C runtime works with associated objects, it's like a global hash map. So that's cool. Let's add a lot of them. No, probably not great for performance. Also probably negligible, but still, it's something to think about. So the problem here is that we have this UI text field and we have a bunch of properties, and we don't want to write setters and getters for every single one of them. So what we can do is change this into an options object or a struct or whatever, and then just have the text field have an options object. And then we only have one property on our extension. We just have options. And then we can simply get it and set it. It's kind of a lot of code, but not that much. Compared to writing Objective-C, it's, walk in the park. And the properties on the options object are just normal properties, no runtime magic. You can do anything that you would normally do, except for one thing. They have to be bridged to Objective-C, because we're using the Objective-C runtime to tack them onto some object. Tradeoffs, right? Where are we right now? What's cool about using extensions and categories is that you can compose many of them. If JV float labeled text field and MH text field were both categories, you could use both. The problem is that we do a lot of runtime sorcery magic stuff, especially when it gets to Swift. You have to bridge this stuff. You have to use a class instead of a struct. It's kind of ugly. It's not very Swifty. I used a lot of the patterns I was talking about today. I mean, like Banana UI Kit, yes, very serious stuff. Let's get a little lighter. I used a bunch of this stuff in a UI view category that I wrote maybe a year ago that allows you to kind of like swipe a view to the left or to the right, right? Like kind of like some dating apps out there, you know. Except in this case, it's Adventure Time because they're great. Cool. So this looks like this, right? You can create an options object that configures how the UI view works. You set its threshold, so basically how far it has to go from the center in order to be considered a swipe. And then you set its, like the block that's called, the closure that's called whenever you do pan to the left or to the right. So in this case, let's imagine that we have maybe a UI web view, because again, it doesn't have to be a particular, this isn't a subclass. So any single view can have these properties. So you can configure a UI web view to maybe like, when you swipe to the left, you bookmark it, and when you swipe to the right, you don't. You like, you know, send it away. So here, if we swipe to the left, we don't bookmark it, and if we swipe to the right, we do bookmark it. And then we pass these options into this category method that sets it all up. So the view category, what's nice about this, actually, going back here, is once you pass the options into this web view, I'm going to copy them. Right? I'm now treating them as an immutable set of options. So even if you take this reference to options all the way up there and you change the threshold, I'm not going to respect that because I've now copied it and I'm now treating it as an immutable set of values. So this view category is configured with a threshold, and when the center of the thing that you're swiping moves outside of this green square, then I swipe it off the screen. But you can't change that, because once you've set up the view, you've given me something, and I'm not letting you change it, which is nice. It's less things to think about. And yes, that is a parameter object being passed into the onPan closure, so I can add things, I can remove things, and everything's fine. So what did we talk about? Parameter objects. You can use them to mitigate change, add, remove parameters, do a lot of cool stuff. You can use this availability keyword to deprecate things and gradually migrate people. That's something that builds trust because you're not breaking people's shit all the time. Sorry, swearing. But there is overhead, right? The other thing that we talked about was extensions versus subclasses. If you use extensions with a little magic, you know, you can give people better flexibility, and so you don't have to force them to choose your framework, right? Which also potentially builds trust. You don't insert yourself into a class hierarchy, and you can just do a little magic. Next is configuration objects, right? So here we, instead of having this method, swipe to choose setup, take a bunch of different parameters on how to configure it, we just create one configuration object and pass it in, kind of like a parameter object. And we prefer immutability when we do so. So once you pass it in down there, I am going to make a copy, and you don't have a reference to it anymore, and that's just what I'm going to use internally to modify the behavior of my class. So yeah, that's pretty much what I wanted to talk about. Once again, if you visit the Quick repo, right, t-shirts, but also I'm kind of excited about Quick. It's a great project, I think. We added one core member here during the conference, and I'm looking for more, especially more diverse core members. We've got a lot of men. So we probably need some different kind of people working on it. And also, if you're interested in the swiping stuff, it's up there, MDC swipe to choose. So thanks very much. Any questions?
Oh, thank you. Thank you very much.